Okay, so you should be on page 514. We're going to do some practice problems together, and we may even do a couple of the independent practice problems together. Let's look at the first two questions. It says to state whether these numbers are prime, composite, or neither. All right. So 51, we know that 1 times 51 will be factors. But are there any other factors? As long as there are more than two factors, this is not prime. So it's not even, but if I look at the divisibility rule for 3, if I add these two digits, what number am I going to get? Very good, we're going to get the number 6. That means this is divisible by 3. So this is going to then have more than two factors, which makes it what kind of number? That's correct. This is a composite. They've changed the pen a little bit here, so hang on a second. All right. Okay, that's very badly written, but you can figure it out. All right, this next one is 23. And again, 1 and 23 are both factors. But if anything else is a factor, this will be a composite number. It's not 0 and it's not 1, so it's not neither. So that's definitely not going to be the answer. Well, is it an even number? No. Is it a multiple of 3 or 9? 2 plus 3 is what? 5. So this is not going to be a multiple of 3 or 9. Is this a multiple of 4? No, that's not one of the numbers you would skip count and land on if you were counting by 4s. It doesn't end with a 5 or a 0. It does not, it's not an even number, so it can't be a multiple of 6. It doesn't end with 0. So what is this going to be if we cannot find another factor for it? Very good. This is an example of a prime number. I am not liking this new pen. Okay. Now let's go ahead and look at this next set of questions. It's asking us to generate an equivalent expression using prime factorization. So basically we have to draw a factor tree and then come up with an equation that only has prime numbers in it. So what is something we can multiply together to equal the number 75? And I want you to think about coins for this. So definitely 5 is going to be a factor, but also 75. If you skip count by 25, you're going to land on 75. So that is actually going to be 3 times 25. Okay. So 3 is a prime number, so I'm going to stop right there. So I don't need to do anything more with the number 3. But what two numbers can I multiply together to equal the number 25? Very good. 5 and 5. Now, the only way to get the number 5 is 1 times 5, so I'm going to circle that as being prime and that as being prime. So if I were to write the equation here, I'm going to start with the smallest number. There's only one of them. So 3 times, and then we have two 5s, so we're going to use 5 as a base and then write the exponent 2. Now let's go ahead and come over here to this -1. So we're going to go ahead and do the factor tree for this. We're just going to do starting with 90 to begin with. This ends with a 0, so I definitely know that 10 is a factor. What number times 10 equals 90? Very good, the number 9. So both of these have other factors. What two numbers multiply together to equal the number 9? Very good, 3. And 3 is a prime number. And 3 is a prime number. 10, 2 times what number? Very good, 5. These are also prime numbers. So now I'm going to write the equation. 2, I'm going to start with the smallest one, times. There are two 3's, so I'm going to write 3 as the base, and then 2 as the exponent, and then finally 5. So this is going to be the prime factorization for this one. Now, because it's negative, the only other thing I'm going to do is write -1 at the beginning of it. So the correct answer for this is -1 times 2 times 3 to the second power, which is 3 squared, times 5. And this is the correct answer for this. Okay, let's go ahead and do some of our some of our independent practice together. So please turn to page 515. Let's look at number 1. So we're going to figure out if this is prime, composite, or neither. The only way this is going to be neither is if this is the number 1 or the number 0. So it's either going to be prime or composite. What we have to figure out is, are there any other factors besides 1 and 47? So is this an even number? No, you're right. Is this a multiple of 3? What is 4 plus 7? 11 is not a multiple of 3. So it's also not going to be a multiple of 9. So is this one of the numbers that we would multiply by 4 and get? 4 times what equals 47? Nothing. So it's not a multiple of 4. So what about 5? Does it end with a 5 or 0? It does not. It's definitely not going to be 6 because it's not a multiple of 3. Does it end with a 0? So this particular number has no other factors. So what is this, prime or composite? Very good. This is an example of a prime number, because the only two factors are 1 and the number 47, 1 and itself. Okay, all right. Let's look at number 3. So we have 99. Is it prime, composite, or neither? Well, 1 and 99 are factors, but are there any other factors that could be multiplied together to equal this number? It's not an even number, so 2 is not a factor. So what about the number 3? What is 9 plus 9? 18. Is 18 a multiple of 3, yes or no? It is. In fact, we can even, if we added 1 plus 8, we would actually get the number 9 as well, and that's definitely a multiple of 3. So this has more than 2 factors. So what kind of number is this? This is composite. All right, this pen is very slow. They've upgraded the software, and I'm getting used to using the pen. Now, number 5. Number 5, is it prime, composite, or neither? What are the factors that we can multiply together to equal the number 1? Well, we could say 1 times what number equals 1? That's right, 1. So actually, this only has one factor. So is it prime, composite, or neither? Very good. This is an example of neither because it doesn't have at least 2 factors. It only has one factor. The number 1 is not prime or composite. Okay. All right, so let's go ahead and we're going to look down here at number 7. We're going to generate an equivalent expression using prime factorization. Okay, I'm going to move this up a little bit here. Okay. I will have to draw a factor tree in order to do this. So we're going to write 66 over here. Oh, really? Okay, we're going to write 66 over here. What are two numbers that multiply together to equal number 66? And we could actually use anything, but I noticed that this is a double number. So 11 is going to be a factor. So what number times 11 equals 66? Very good, the number 6. 11 is a prime number. Only numbers that are going to multiply to make the number 11 is 1 and 11. So we're done with that. What about the number 6? What two numbers multiply together to equal the number 6? It's an even number, so the number 2, what times 2 equals 6? Very good, the number 3. 2 is a prime number, and 3 is a prime number. So if I write the equation for this, I'm going to start with the smallest number, 2 times 3 times 11. Okay, let's do one more. We'll do number 9. All right, so 9 is automatically going to start with a -1 because it's a negative number. So let's find out what are the other numbers. I'm going to go ahead and start this factor tree over here. So 48. What two numbers multiply together? And we could start with any two numbers to multiply together to equal the number 48. I know that half of 48 is 24, so let's do 2 times 24. We could have said 4 times 12. It doesn't matter where you start. So this is a prime number, so we're going to stop that one. That one's done. So what about 24? What two numbers multiply together equal number 24? Quite a few things. 2 and 12, 3 and 8, 6 and 4. Let's do 6 and 4. So 6 and 4 are both even numbers, so they have more factors. I'm going to go ahead and add 2 more for 6. What two numbers multiply? Well, I said it was even, so 2 is going to be 1. I'm going to circle that. That's the final number for a prime number. 2 times what is 6? We already said that is 3. And what two numbers multiply together to equal number 4? Very good. 2 and 2. Okay. So we are done because all of the factors are circled. So now I need to write my equation. I'm going to look for the next smallest number, and that is going to be the number 2. How many 2's are there? There's 4 of them, so we're going to write 2 to the 4th power. And then I'm going to multiply this by the final factor. And I can go back here. Okay, I've got that 2, I've got that 2, I've got that 2. So the only thing I have left is the number 3. And this is the equivalent expression that's prime factorization. All right, I hope this helps. Please complete the rest of the independent practice, and you'll be turning this in tomorrow.